So our subject is logic circuit design. Now, what do you mean by logic circuit design? We are going to design a circuit based on logic. So when you talk about logic circuit design, first of all, you need to know what is an analog circuit and what is a digital circuit. Now, analog signal, you must be aware, analog signals are signals which change with time. What changes? Mostly voltage. Digital signal has a constant value for a particular amount of time. So here 0 to t1 it has a value high, and t1 to t2 it has a value low. So in an analog signal you can say that for every time you have a different value. So this is the difference between an analog signal and a digital signal. So in last class, last semester, you must have learned about many analog circuits like amplifiers, etc. Now in logic circuit design, we will be dealing with digital signals. All the circuits we are dealing with are digital circuits. So in digital circuits, we have a fixed value. That is, you have only two levels. One is a 0 and a 1. So when we talk about zeros and ones, we need to know about two types of logic. One is positive logic and another is negative logic. So what is a positive logic? Positive logic is, I said that you have only two levels, a 0 and a 1. If 0 is treated as a low and 1 is treated as a high, then it is called the positive logic. The reverse case, that is, if 1 is treated as a low and 0 is treated as a high, then that is the negative logic. That is normally what we say, that is 0 is less and 1 is greater. That is the positive logic. And the reverse case, that is 1 is low and 0 is high, that is the negative logic. So normally in digital circuits, we will be dealing with positive logic circuits. Negative logic circuits are there, but then you won't be dealing much with the negative logic. Mostly we will be dealing only with the positive logic circuits. So coming to this, first of all, your first module is basically based on different types of number systems. You must have already learned in school, +1, +2, about many of the number systems. So we have to learn about binary, octal, hexadecimal, and decimal number systems. So when you talk about these number systems, decimal has a base 10. Next is binary. In binary, we deal with 0 and 1, only two numbers. So it deals with just two numbers, so it has a base of 2. Octal means 8. So it has 8 numbers in total. 8 numbers in total means it deals with 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7. There is no 8 in octal. Okay. So it deals with 8 numbers. So the base is 8. Hexadecimal. Hex means 16. So it deals with numbers from 0 to 15 actually. But then there is a change there. We'll talk about it. So 0 to 15, that is total of 16. So the base is 16. Okay. So these are the types of number systems which we will be dealing with in our first module. Okay. So when I told about hexadecimal actually deals with hexadecimal deals with 0 to 9, and 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. So it is 0 to 9, then A, B, C, D, E, F. So these are the different types of number systems. So what we should study is number conversions from one system to another. So that we will be dealing with a lot of examples. You'll be given some homeworks also to find out, convert one system to another. So first of all, we all know about decimal numbers. So decimal number means, suppose you have a decimal number, say 58. So how do you say that this is a decimal number? How do you notate that this is a decimal number? We notate it as 58 to the base 10. So when you see this base 10, that means it is decimal. So always remember to write the base, especially in the first module when we will be dealing with different types of number systems. We should talk about different bases. Okay, so just if you write, say suppose you are writing 12, maybe you meant it as a decimal number 12, but 12 can be decimal, it can be octal also. Okay, so 12 means it can be decimal, it can't be binary, it can be octal because 1 is octal and 2 is octal, so it can be octal. It can't be hexadecimal, it can be hex also, octal or hex. Okay, 1, 2. So unless and until you specify the base, you can't understand what type of a number system this belongs to. Okay, you have 12 to the base 10, 12 to the base 8, and 12 to the base 16. All these have different values actually. Okay. So you should know the base. Now let's start with a small number, small conversion. Convert, say, binary to decimal. Suppose you have a binary number. This is a binary number 110 to the base 2. Base 2 notates that this is a binary number. So you need to convert this to decimal. That is, this is equal to what to the base 10. So in order to find this, first of all, what we'll do is, we'll write 110. Here, in the case of binary numbers, the rightmost bit, this is called as the LSB. LSB means least significant bit. And the leftmost bit is called the MSB, or the most significant bit. So what is the significance of an LSB or an MSB? An LSB has the lowest weight and an MSB has the highest weight. Now what is the weight? In the case of this binary number, the weight of the LSB is 2 raised to 0. Why 2? Because this is a binary number. Raised to 0 because it is in the LSB. So you start from rightmost bit LSB has a value base to the power of 0. Next we'll have base to the power of 1. Next we'll have base to the power of 2. So in this particular case, we have only 3 bits. What is a bit? Each binary digit is called a bit. Bit is the binary digit. That is 0 or 1 at a particular position is called a bit. So how do you write the weight? From the rightmost value, here in this case it's 0. So 0 has a weight of 2 raised to 0, where 2 is the base. 1 has 2 raised to 1 and this one has 2 raised to 2. Clear? So with this, we need to find out the decimal equivalent of 110. So how do you write that? This one. So 1, this one, into this weight 2 raised to 2 plus this one into 0. So that will be 2 raised to 2 is 4 plus 2 plus 0. So that is 6 to the base 10. So the value of 110 to the base 2 is 6 to the base 10. Likewise, we can find the values of different binary numbers or different these are some binary numbers. We will find the decimal equivalent. So suppose you want 0, 0, 1. This is 0, 1, 0, 0, 1, 1 and 1, 0, 0. So 0, 0, 1 means, how is it? This is has a value of 2 raised to 0, 2 raised to 1, 2 raised to 2. So 0 plus 0 plus 2 raised to 0, 2 raised to 0 is 1. 0 plus 2 raised to 1 plus 2 raised to 0, 2 raised to 1 is 2. 0 plus 2 raised to 1 into 1 plus 2 raised to 0 into 1, that is 3. So 100 is 2 raised to 2 into 1 plus 0 plus 0. 2 raised to 2 is 4. So this is 0 plus 0 plus 1 into 2 raised to 0. This is 0 plus 1 into 2 raised to 1 plus 0. This is 0 plus 1 into 2 raised to 1 plus 1 into 2 raised to 0. This is 1 into 2 raised to 2 plus 0 plus 0. So this is how you convert binary to decimal. Or in general, we can say that in order to convert a particular number in a particular base to decimal, that is, binary has a base of 2 and decimal has a base of 10. So in order to convert any number in any number system to decimal, you have to multiply each digit with the corresponding weight. So this is till 4. Now if we take it to the next level, next is 101, 110, 111, 1000, 1001, etc. So here this has a base of 2 raised to 0, 2 raised to 1, 2 raised to 2, and for these two cases you have an extra bit which has a weight of 2 raised to 3. Okay, so this will be 1 into 2 raised to 2 plus 0 plus 1 into 2 raised to 0. So that is 4 plus 1, that is 5. This will be 1 into 2 raised to 2 plus 1 into 2 raised to 1 plus 0. That is 4 plus 2, that is 6. Here 2 raised to 2 plus 2 raised to 1 plus 1 into 2 raised to 0. So 4 plus 2 plus 1, that is 7. Here you have only 1 and that is in the position 2 raised to 3. So 2 raised to 3 into 1, that is 8. And here you have 2 ones, one in 2 raised to 3 position and another in 2 raised to 0 position. So this will be 8 plus 1 equal to 9. So in short, there is an easy way by which you can find out the equivalent decimal value of a binary number. So how do you do that? We'll just write the values, that is, instead of writing 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, we'll just write it as 2 raised to 0 is 1, 2 raised to 1 is 2, 2 raised to 2 is 4 and 2 raised to 3 is 8. That is 1, 1 into 2, 2, 2 into 2, 4, 4 into 2, 8. If you need more digits or more bits, then you just need to multiply 2 with the previous digit. So 8 into 2, 16 is the next one, 32 is the next one, likewise. So with this, if you write, say, 1010 is my number. So 1010 will be 8 plus 2, that is 10. 1011, that is 8 plus 2 plus 1, that is 11. 1100, that is 8 plus 4 equal to 12. 1101, 8 plus 4 plus 1, that is 13. 1110, that is 8 plus 4 plus 2, that is 14. And 1111, that is 8 plus 4 plus 2 plus 1, that is 15. So if you are asked to write from 0 to 15, just start writing it with this 8421 code and just fill it up. So we'll need this in all the modules. When you are dealing with digital electronics, you need this all the time. So you just need to write 8421, that is for maximum 4 bits. If you need higher order bits, then you just need to write it as 16, 32, etc. So 8421, now we are only dealing with 4-bit numbers, maximum 4-bit. So this must be a repetition for those who have taken computer in +1, +2. But then there may be many who have taken biology and may not be aware of these portions. So others, please listen and refresh your memory. So this is 8421. So we'll start with 8421. So we'll start with 0. 0, for 0, you have to multiply each weight with the corresponding 0 or 1 plus next bit with the corresponding weight likewise. Okay. So 0 means there is no value, so it is 0 for all. So here we are representing all the numbers in 4 bits. Okay. So for 1, we need only 1 into 1. So here 1. Actually just write 1, that is enough. But then since we want to represent here in 4 bits, we'll write it as 0001. Both are same. You write it as 1 or 0001, all are the same. So 2 means 2 into 1. So 2, you have a 1 and 0 in all the other places. 3 means you don't have a 3 here. So 3 is 2 plus 1. So you have to write 1 here and 1 here. So these two are zeros. And 4 means you have a 4 here, so a 1 below that, rest is 0. 5 is 4 plus 1, 4 and 1, and 6 means 4 plus 2, 7 means 4 plus 3, so 2 and 1, 8 means 8 and rest is 0, 9 means 8 and 1, so the rest is 0, 10 means 8 and 2, rest is 0, 11 is 8, 2, 8 plus 2, 10, plus 1, 11. Okay. So then 12 is 8 plus 4, 13 is 8 plus 4 plus 1, 14 is 8 plus 4 plus 2, and 15 is 8 plus 4, 12, 14 plus 1, 15. So the largest number you can represent using 4 bits is 15. So that is it about binary numbers. How do you convert a binary number to decimal number? So you can take up any number of questions to convert a number to the equivalent decimal number. 0 to 15 anyways you have to know by heart. You will eventually be able to write it in order. You should be able to write it in order. Okay, so don't follow the method by which you write zeros then ones. Don't write like that. Mostly it's seen that in schools they teach you like that, so don't do that. That's not the scientific way of writing a binary number. Always write it like this, and when you write a number of times, eventually that will become by heart to you.